So kind of instead of looking at one of the quotes, we're going to look at one that's very similar to something in the notes, but it's very important for us to kind of learn about what it means to look at an inequality that has a negative sign in it. So that's what we're going to look at right now. I'm just going to make up a question here, and we're going to just take a look at it. So it's not from the notes, but it's very similar to something that can appear in the notes. And that's something like solving some inequality, something like negative 3x is greater than, let's say, 9. Something like this, and a really big important part about this is that we have a negative sign. There's a negative with our variable. And there is a really important part about this that's very, very different from our previous unit. And you might kind of remember our previous unit, that was something like negative 3 equals 9, in which case then we could pretty easily solve by dividing both sides by negative 3 and getting our answer of x is equal to negative 3. And that was last unit, and the techniques in which we got down to isolating for x are still going to be the same in this unit. However, there's going to be something very, very special that we have to do with this negative sign. And that's going to be something that is going to take a little bit of getting used to. You probably haven't seen it before, and that's really where our discussion is going to go. What I want to make sure that we know about is that all of our rules from our previous unit of solving linear equations are still applicable here. We can still divide, we can still multiply, we can still add, we can still subtract. But when we come into dealing with an inequality, it's going to be a little different in how we deal with the negative. So let's take our question here, and we're going to solve this inequality by isolating for our variable. Now, I want you guys to notice that my term with the variable in it, it's already by itself on one side of the inequality sign. So we don't have to do any work getting all of our terms together, but we do have to do some work to try to get x by itself. What I'm going to propose for us to do is I'm going to add 3x to both sides. Now, you might think, why on earth would you do that? Because that's not getting rid of our coefficient, but just kind of bear with me here because it's going to kind of get us to see something. These two, of course, are going to reduce out or cancel out with each other, and I'm going to be left with this. And then I'm going to now subtract 9 from both sides. And I really want you guys to just kind of get in the habit of using this vertical style of doing your work, where you kind of see that I start here and I work my way down, rather than maybe some conventional way of, like writing English or something like that, where you work side to side. We are inevitably going to kind of bring it back up and work off to the side, but I just want you guys to get a little bit of the hang of that. So let's kind of take a look at where we are. We started with negative 3x is greater than 9. Added 3x to both sides, and then we have something like negative 9. Then we subtracted 9 from both sides, and then we have negative 9 is greater than 3x. I want you guys to take a look at this because it's pretty important for your knowledge to recognize that these two statements, they're actually identical. There's nothing changed from these other than flipping one from one side and one to the other side. The inequality is still opening. In terms of the way that it looks, it's still opening in terms of the same way. You could still see still opening this way. This is not the same as me just reordering this. I don't want you guys to get confused with me just reordering this inequality with something like this, where I put 9 is less than negative 3x. These two things are equivalent as well, but it doesn't help us out. I'm not trying to do this. What I'm trying to do is trying to get our term with x positive. Because now what I can do here is I can just kind of handle this problem as normal. I can divide both sides. I'll just rewrite it for myself, but I can divide both sides by 3. And I can see that my final answer to solve this inequality is negative 3 is greater than x. This is a little awkward to say, so I'm just going to rewrite it, and I'm going to put it as this. Now the inequality is still still opening to the same value. So I know that this here is my answer. I like to have my variable first, and this is my answer here. Notice how, in order to get to this, we had to make our x term positive by adding it to both sides. This is very, very different than if you were to just use this question and use the technique that we learned in our previous unit. And by that, I mean, hey, why don't we just divide both sides by -3 and then come with x is greater than -3. There is a very large difference between these terms. These are not equal. We cannot say that these are equal to each other because look at the inequality, right? One's using a less than sign, one is using a greater than sign. So which one is correct? And what we got to realize is that we cannot use this method, our old method of solving linear equations for inequalities. This will not work. And it's for this reason, where we have our inequality. Essentially, you can see that it's flipped from our original position because we added 3x to both sides. This is the correct way to do our inequality here. This is our correct way. So we kind of have to ask ourselves, do we have to do all of these steps in order to solve the equation or in order to solve the inequality? And the answer is no, we don't have to do all of these steps because that would be very tedious, but we can't rely on our method before because it's incorrect. We're saying that x has to be greater than -3. If you try to plug in or verify a value that is greater than -3, it will fail this inequality. So this method is wrong, but there has to be a shortcut for us to do this. So I'm going to take this question again, but I'm going to teach you how to do a little bit of a shortcut instead of showing all these steps. So we're going to start with the same question as before. I just want to make sure that I have the same one. Okay, so we're going to say greater than 9. And I'm going to use the same method that we used in our linear equations. So I'm still going to use the same method by dividing by -3. Dividing by -3. But this time, what I'm going to do is, since I divided by a negative, right? Since we are dividing, and the rule would also apply to multiplying by a negative, we're going to flip our inequality. We are dividing, or I could say multiplying, by a negative. And what this means is that we are changing the potential sign of x, right? We don't know what x is right now. We don't know if x is positive. We don't know if x is negative. But we know that if we divide by a negative number, that is going to change whatever the sign of x is going to be, right? When we either multiply or divide by a negative, it's either going to, a negative times a negative is a positive, or a negative times a positive is a negative. It has to flip its sign. So when we do that, we are dividing by a negative, we must, and we absolutely must, flip the inequality. And that's one of our rules that we have to learn about inequalities. So when we go ahead and write x is and -3, we have to change our inequality to face the other way. And that is a really, really big idea of this unit. Since we divided by, we had to flip the inequality. We have to flip it because we're dividing by a negative or multiplying by a negative. And for the real reason behind that is because this method of math, where we add 3x to both sides, has to hold true whichever method we use. We know the answer is x has to be less than -3. And if we did some math like we did from before and we didn't flip our inequality sign, we wouldn't get the agreement. So a really big concept of this entire unit, when we are solving for an inequality, we have to make sure that we flip an inequality sign to get our x is less than -3, since we're dividing or multiplying by a negative. You'll see this come up time and time again, and I hope that you guys can realize that it's because we're dealing with negatives that we have to flip our inequality and flip the way that we view it. Very, very similar of how we read that number line in the negatives. As we go deeper into the negatives, right, these numbers here are going to be less than -3. It's going to be -4, these are going to be -5, -6s, right? These all the way over here are going to be -2, -1, 0. And it's this kind of shift in how the numbers work when we're dealing in negatives, meaning why we have to flip our inequality sign.